chapter. We're in chapter 10, comparing two populations. 10.1 is proportions, 10.2 is means. And we started with an activity the other day doing comparing whether or not people yawned. And so keep in mind that eventually we're gonna have a lot of different options to choose from when we do a confidence interval or a test, and so we have to know what kind we're doing. And so now that we're comparing two populations, we have a two sample test option. But you also have to know if you're doing proportions or means. So proportions is for categorical data, like yawning or not, whereas means is quantitative data, like number of hours of sleep someone got the night before. So you have to start to really pay attention to which category you're doing for each problem. And eventually when we get to means in 10.2, we'll do the tests, we'll do the intervals and tests on our calculator more frequently once we know what's going on. It's just that if you do that on a test, you have to be sure you're doing it perfectly, because you can't get any partial credit if you do the computation on your calculator and anything is wrong. You can't get any partial credit at all. So what I'm going to do is just do the formulas for proportions here, and I'll try to make it look like what's on your AP formula card as much as possible, if it's actually on there. And then we'll do the examples so that we have context. So proportions, there's two things you need to be able to do for two populations. You have to do a confidence interval or do a hypothesis test. So when you're doing confidence interval, I'll just write confidence interval, CI. You have this formula that says you take your statistic, and then it's plus or minus the critical value. In this case, it's going to be Z star because we're doing proportions, but we'll do the example in a second. So plus or minus your critical value times the standard deviation of the statistic. And the statistic in this case is the difference of two proportions. So you have that on your formula sheet, and it also says, there's a table that says the difference of sample proportions for this. It says it has the words difference of sample proportions, and it tells you that since that is your statistic, is the difference of two sample proportions, what you plug in for this part is the square root of P sub 1 minus P sub 1 over N sub 1 for one population. And then you plug in for your second population P sub 2, 1 minus P sub 2 over N sub 2. So you're given all that, and so that's when you're doing a confidence interval for proportions for two populations. That's what you'll use. We'll do that in an example in just a second. And then if you're doing, it also says on the formula card that the test statistic, if you're doing a hypothesis test statistic is the statistic minus the parameter meaning for the population, over the standard deviation of the statistic. But it's different than, the formula is different than this, and it's not on the AP formula card. So it says over standard deviation of statistic, but to compute this, the formula would be this, and it's not given on your formula card. So let's say normally when we do the hypothesis test for the difference of two proportions, H naught will be that there's no change, so that there's no difference. So P1 minus P2 equals 0. And then H sub A will be usually greater than 0 or less than 0. So for that, then when you compute your test statistic, you say Z equals, And then the statistics, since it's the difference of the proportions, the sample proportions, you're going to do P1 hat minus P2 hat sample, proportion 1 minus P2, and then since the difference is 0 for what we're testing, you would say minus 0 for that. That's for the parameter, since H naught is that the difference is 0, over, and now for the standard deviation of the statistic, we're going to use what's called a pooled proportion, so P sub C, and I'll show you how to, it's very easy to find. 1 minus P hat sub C, that's the pooled proportion, and I'll explain in a second, N sub 1 plus P hat C sub C 1 minus P hat sub C over N sub 2. And so it looks similar to the other standard deviation of the statistic, but the pooled proportion, which I'll show you, you just use both populations. So this stands for the pooled sample proportion, which is really easy to find. You'll see in the example. Use the pooled sample proportion. And those are all the formulas you need for this section, but we really need to do them in an example to make sense of them.